Okay, quadratic functions and their graphs. When I talk about quadratics, I'm talking about the equation based on y equals x squared. Okay, so we're doing just a little bit of several different things, working with standard form, working with vertex form, which is what Algebra 2 learned yesterday, or the last 2 days as they were working with vertex form. I think they get ready to learn standard form today and tomorrow. Okay, we're going to kind of review it all at once here. So, example 4, jumping right in. Describe how to transform the graph of f of x equals x squared into the graph of the given function and sketch the graph by hand. So, there's 2 things happening here. First of all, the word describe, which means I'm looking for words. Words in math, I know, crazy thought, right? Words in math telling me what this graph is going to do. Notice it's based on the original graph of f of x equals x squared. Then after we describe it, we're going to do our best to sketch. So not plug it into the calculator and copy the calculator off the graph, but use what we know. Okay, g of x equals negative 1/2 x squared plus 3. Okay, guys, this is Algebra 2, first semester, big time. Chapter 2, I introduced transformations. Chapter 3, we used them again. And my kids are in Chapter 4 right now, and they're using them again.
We know it's up to 3, like a vertical stretch.
We went over all.
Yeah, and we've used them this year in pre-cal, yes. So transformations should be coming through. What kind of transformations do you see here?
Up 3.
Up 3?
And it's a vertical stretch by 1/2. Dang it. Yeah.
Okay.
Just add it.
I think I've heard everything here. I just have to get it all organized. So the plus 3, the number at the end that's not with the x, not in parentheses, is up or down. So it's up 3. The 1/2 that's multiplying by that x squared is either a vertical stretch or compression, or do you like shrink or stretch?
I like shrink and stretch.
I can't remember.
It's a stretch because it's less
Okay.
than 1.
I couldn't remember what words I've used, but I don't care. Stretch, we usually say stretch. Shrink or compression, I'm fine either way. They're interchangeable in my brain. So, which was this?
Stretch.
1/2 is less than 1?
I thought less than 1 was a stretch because it's.
No. 1 greater than 1 is your stretch that pulls up. We're talking vertical here. But a number between 0 and 1 is your compression or shrink. So I have written in my notes a vertical shrink by a factor of 1/2. And someone said the negative is a reflection across the x-axis. So in that little space on the left, I'm going to kind of write all this information down. That there is a vertical shrink by a factor of 1/2. There is a reflection across the x-axis, and there is a translation or translate up 3. I can probably zoom that in more so you guys can see it.
Less than 1, it's a shrink.
If it's a number between 0 and 1,
Between 0.
right? Well, because less than 1 is negative, and the negative the negative is a reflection. So you look at the number without the sign. So you could say less than 1, but officially it's still listed as a number between 0 and 1. Okay. Now, I would love to say my Algebra 2 kids could tell you what do your basic dots look like on a y equals x squared.
Yeah.
Okay, it's the parabola, 0, 0, 1, 1, 2, 4 is the right side, and then the left side, you just reflect over those, right? Like, that's what my Algebra 2 kids we've worked on the past 2 days is they need to know 0, 0, 1, 1, 2, 4. So a year ago, that's what we were working on. Okay? Now. Okay, I'm going to put in some tick marks I'm pretty much,
I just sketched it.
I've got 3 tick marks left and right. I'm going to go at least 3 tick marks up and 3 tick marks. I guess I pretty much went 3 tick marks each direction. Okay. There's a lot to think about here. We have to shrink it, which when you shrink it, remember that doesn't really affect the vertex. What does a vertical shrink affect?
Yeah.
Do I use it on the X or the Y coordinate, I guess is what I need to. If it's a vertical,
Why?
we're going to use it on Y. Okay, so when we talk about that vertical shrink, normally 0, 0, 1, 1, 2, 4, well, 0, 0, half of 0 is still 0. Instead of 1, 1, when we go to do that part, half of 1 will be 1/2, so it'll be 1, 1/2. 2, 4, we'll still go over 2, but half of 4 is 2, so 2, 2. So that's kind of your new XY chart. Does that make sense? Now, we also have to reflect this across the x-axis, so what's that mean? Instead of a right side up parabola, it's going to be an upside down parabola. And we have to move this up 3. What's that mean? My vertex is going to go up 3. So my vertex that normally would be at 0, 0 is going to be at 0, 3. Without the shrink, I would go over 1, down 1, and over 2, down 4. Right? That would be your typical parabola. But because we have that vertical shrink, instead of going over 1, down 1, I'm going to go over 1, down 1/2. Instead of over 2, down 4, I'm going to go over 2, down 2, because I shrunk each of my y coordinates. Over 1, down 1, over 2, down 2.
Wait, why is it 1 and 1/2?
Because of the shrink, our normal XY chart on a parabola was 0, 0, 1, 1, and 2, 4. Because it's x squared, right? You're squaring each x value. But the vertical shrink of 1/2 takes each y value and cuts it in half, or multiplies it by 1/2.
So that's why it's like,
So that's why instead of 1, 1, thank you, I did 1, 1/2. Instead of 2, 4, I did 2, 2. Because it's a shrink. Had it been, say, a stretch by 3, we would have taken each of those y values and multiplied them by 3. Okay? Are we somewhat okay with this?
yeah, that's good.
Exactly. It's a refresh. I mean, essentially you did some of, well, we didn't do this to this degree a year ago. But, I mean, it's pulling stuff from a year ago. Okay, shall we try B? Should be able to get through B and might not get much farther, but. So B, h of x is 3 times x plus 2 quantity squared minus 1.
Yes, down 1.
Down 1,
Down 1.
left 2, stretch 3. We got all that?
Vertical.
Valid point, vertical stretch, yes. Just because a horizontal stretch does work totally different. And we don't usually see those very often. We usually convert and do verticals. So, much. Okay, so vertical, and why was it a stretch? Because that 3 is greater than 1. Okay. So vertical stretch by factor of 3, translate, it doesn't really matter what you do first, left 2 and down 1. Okay, I went left 4, down 4, left, right, down 4. You can start by going up 4, but that's going to have to change. We're going to have to go up higher than that. I end up going into the words type thing on this problem. Okay, here's the deal, guys. With these transformations, think about, easiest way for me to do this is think about your stretch and then move your vertex. Okay, because when we do that stretch of 3, what's that going to mean this time? Okay, it's a vertical stretch, so we're multiplying the y by 3. So 0, 0 would still be at 0, 0. 1, 1 becomes 1, 3 because you're multiplying that y value by 3. 2, 4. 2, 12 because we're multiplying that y value by 3. Okay, so now what's our vertex going to do? Okay, so I'm going to take my vertex, left 2, down 1. Now, when I go over 1, up 3, over 1, up 3 means I'm really going to end up the ordered pair negative 1, 2. Does that make sense? And then that would also put me at the ordered pair negative 3, 2.
Wait, can you do the second dot again? What was that?
So from my vertex, instead of going over 1, up 1, I went over 1, up 3
Because you times it by 3.
because of the stretch of 3. Okay? And then normally we'd go over 2, up 4, which going over 2 is going to take me to the y-axis. But instead of up 4, because we stretched by 3, we're going to go up 12, which really means I need to be able to get to where? If we're going up 11, and considering I already went down 1, excuse me, I gave myself away there. If we're going up 12, from my position of below at negative 1, that really means I have to be able to get up to 11. Does that make sense?
Yeah.
That's what I was trying to say, and I gave myself away there. So we're going right 2 and up 12 total. Which for me is at the top of the word of. We'd also have to go left 2 and up the other way. Definitely a stretch, yes?
It's hard to make this look like a parabola.
I mean, there's my parabola. You know,
That looks too empty.
go with what we get here. Okay, perfect place to stop. Tomorrow, we will continue notes. Always a chance of work time. Wishful thinking says we might get some work time tomorrow. I can't guarantee it, though. I don't know. We'll see. We'll try it. And then this homework will be due Friday. And then we'll do lesson 2-2. And lesson 2-2 takes us like all of a day. It's like a really short lesson. So, have a good day, guys.